So these are the notes for 17.3, and we're going to be focusing on using proportional relationships, and really the question we want to answer today is how can we actually use these things called similar triangles to solve problems, right? Like, so why do we need to know about similar triangles? How does this help us? And what can we use them for? And so today we're going to talk a little more about some real life contexts of how we could use these to help us solve certain issues. Now, the first thing I want you to do is there's a couple of questions here that say, what do you notice and what do you wonder about these pictures? And so I want you to kind of pause the video here in just a second and just write some stuff down. I'm going to also write some stuff down eventually of things you might have noticed, but I want you to try first. So go ahead and just write some things down that you notice about the pictures that you might wonder, that you might have questions of, and I'll answer those in just a second. So go ahead and hit pause. So some things you might have noticed, right, especially about these first two. Maybe the first question you had was, how tall is the flagpole? Or maybe, you had a question of how tall are the trees? Maybe you thought, how many steps are there, right? You notice these steps leading up to the flagpole, right? How many steps? And again, like, you don't necessarily have to ask these questions. These are all things that you might have noticed, and you might have noticed a few more, and that's totally fine. And maybe you looked at this bottom one and said, okay, well, how much taller is the flagpole than this guy right here, right? Whoever that is. Okay, it's not me, I promise. But, maybe that was a question you had. How much taller is the flagpole than the person? Okay, so even just looking at these couple pictures, right, there's all kinds of questions you could have asked, right? You could have asked, what is the slope of the hill? Just all of those types of questions. And so today, right, we're going to talk about finding the height of those types of objects. So down here at the bottom, it says Sid is 72 inches tall, and so to measure a flagpole, he stands near the flag. His friend Miranda then measures the lengths of Sid's shadow and the flagpole's shadow. Find the height h of the flagpole. So in this diagram down below, here is Sid. Okay, I'm going to draw Sid for you. There he is. He's having a good time. He's got some nice hair. Boom. Okay, there's Sid. He's having a good time. And he's 72 inches tall. Now, the reason we can do this is because these dashed lines right in here are rays of sunlight, right? So we have the sun that's somewhere way over here, right? Ta-da, there's our sun. And it's shining down these rays of sunlight that come down, and they hit us and the flagpole, right, or Sid in this case. They hit these things, and then that creates this shadow down to the ground. Okay, if you've never experienced a shadow, I'm going to have you go outside tomorrow and you can see what a shadow is. Okay, but there's your shadow. And so by doing this, okay, these rays of sunlight are parallel with each other. So because of the way sunlight and their rays work, those two lines are parallel, which means not only do we have 90-degree angles because we're perpendicular to the ground, we're standing straight up, perpendicular to the ground, but these angles right here are also going to be congruent, because if you connect these lines here, this is just the ground that everything's standing on, right? And we have these two parallel lines. What kind of angles is this one and this one? Well, those are corresponding, which means they're congruent. So since we have similar triangles, we can use proportions to set up some fractions to help us with our problem here. So I know his height is going to compare to the flag's height. And that's going to have to be the same proportion as Sid's shadow to the flag's shadow. So we're going to compare heights to heights and shadows to shadows. So Sid's height, it tells us, is 72 inches. The flag height, I don't know, that's what we called H. Sid's shadow was 48 inches, and the flag was 128. And so now we've set up a proportion. We can use our cross product property. 72 times 128 equals 48 times H. And 72 times 128 is going to give us 9,216 equals 48H. Divide by 48. And so H equals 192 inches. So if Sid is 72 inches, which if we think in terms of feet, would be 6.0 feet tall, and 192 inches, oops, that's not 92, divided by 12 inches per foot is 16 feet tall, which if you think of a flagpole, sounds about right. Okay, so in this case, since they gave us it all in inches, we only need our answer in inches, but just to give you a perspective, since we like to work in feet. Okay, so if he's 72 inches tall, the flagpole is 192 inches tall. And so again, it's knowing that relationship of the sunlight with those rays being parallel. Then we can set up a proportion using our heights and then our shadows. Okay, the lengths of our shadows. So next time we meet in class, we're going to do this little project here that says determine the heights of 3 places on campus. So all I want you to do tonight is think of and write down 3 places. Okay, you've got 1, 2, and 3. And so go ahead and write the name of some things on campus that you are going to go find the height of. And so that can be the flagpole, that can be the library, it can be the gym, that can be, you know, the Apache statue right outside my classroom. That can be one of the Apache 4 poles that have, you know, the responsibility and all that stuff out there. It could be a tree, right? Anything. I just want you to write down 3 places on campus, and then tomorrow I'm going to next time we meet in class, you're going to actually go out and find those heights. You're going to use similar triangles. We'll talk about kind of how that'll work. But that's all I want you to do right now is just start by naming those 3 things. Okay, so think of 3 things that you might want to go find out, and I'll have you guys partner together eventually. But go ahead and start thinking of those 3 and write those in when you turn in your notes. Now down here as an example, we have define the distance D across the gorge. So this grayed out part here is this gorge, right, that would have water in it. So it says a student identifies points as shown in the figure. So they make these triangles here using those points, J, K, L, M, and N. And so it wants us to find letter D. So I want you to actually try this on your own. I'm going to have you pause this in just a second. And then I'll continue solving the problem. That way you can see if you set it up correctly. So go ahead and pause the video right now and then press play to see the answer. So for this problem, again, the first thing you want to do is make sure these are similar triangles. You should notice that we've got some right angles in here. Got a right angle at angle K, and a right angle at angle M. And then the other angles you should notice are angle L and angle L. So again, are these triangles similar? Yes, by angle, angle. So you first have to establish that they are similar. And then from there, okay, we know that triangle JKL is similar to triangle NML. And remember, the order of those do matter, right? Angle J up here at the top is the only one by itself. It wasn't the right angle. It wasn't our green angle L. We had these two angles, angle K and L, that were marked. So J has to go with the other one that wasn't marked, which is N. Our 90-degree angle, angle K, matches with angle M. And then L and L have to go together. So now we can set up some proportions. We know that we know that J to K, first and second, matches up with N and M. And so the other two sides that we also know are from K to L. And if we look at our lines again, K and L, the last two must be M and L. JK we know is D, and M we know is 35 meters. KL is 24 meters, and ML is 42 meters. Again, cross product property, multiply across. 42 times D equals 35 times 24. 42 times D is 42D. 35 times 24 is 840. Divide both sides by 42. So D equals 20. And in this case, what are the units? Meters. Okay, so again, you first need to establish that they are similar, and then from there, we can use proportional sides. Okay, set up a proportion, which was this part right in here. So we use that proportion, substitute in our values, and then solve our proportion from there. So again, how can we use similar triangles to solve problems? Go ahead and answer that question as you submit your notes. And then again, we will work through this project up here next time I see you in class.